For the longest time, we believed in the Bohr's model of an atom, in which there was a nucleus where the protons and neutrons were located, and the electrons were located in fixed energy level called the electron shell. It is similar to our planetary motion, where the sun is in the center, like the nucleus, while the Earth and the other planets revolve. The three subatomic particles of an atom are neutron, proton, and electron. The symbol for a neutron is N, proton is a P, electron is a E. The neutron and proton are located in the nucleus, while the electron is located in the electron cloud. The relative charge of a neutron is 0. It has no charge. A proton is a +1, and an electron is a -1. In general, neutrons are the biggest of the subatomic particles. However, we assume that it's very close to the size of a proton. An electron is about 1/2000 times smaller than a proton. The periodic table gives us several unique information of an element. Located on the top, left, middle, or right corner is the atomic number. The atomic number is unique to each element. It gives us the number of protons and the number of electrons when it's neutral. If the number of protons increase, it is no longer that element. So for example, carbon has an atomic number of 6, so it has 6 protons. If I add an extra proton, it is no longer carbon, it is nitrogen. The symbol of the element always starts with a capital letter. If it has a second letter, it is always small. Below the symbol is the name of the element, and below the name of the element is the atomic mass. The atomic mass is the average mass of all the naturally occurring isotope. It is always a decimal number. The units are atomic mass units, AMU, or grams. There are 3 types of atoms. The first type are neutral atoms. Neutral atoms have no charge. Therefore, the number of protons equals the number of electrons, which is also the atomic number. Ions are charged atoms. The number of protons do not equal the number of electrons. There are 2 types of ions, cations and anions. A cation is a positive charge. Therefore, the number of protons is greater than the number of electrons. It loses electrons. Remember, only electrons move. Anions are negatively charged atoms, in which the number of protons are less than the number of electrons. Therefore, it gains electrons. The easiest way to memorize this, anion is a negative ion. The third type of atom is an isotope. Isotopes are same atoms with different number of neutrons. Therefore, the number of protons and atomic number are the same. The general format for writing isotopes: X stands for any element symbol, A is the mass number, it is a superscript, Z is the atomic number, and that is a subscript. You will also see the format for writing isotope as the symbol hyphen the mass number, or the name hyphen mass number. Here are all the different ways we could write an isotope. So the first one is the symbol hydrogen. 1 is the mass number. Down here is the atomic number. The mass number is given as a superscript. The atomic number is given as a subscript. We have hydrogen here. The superscript is the mass number. Atomic number does not need to be given because since you know what the element is, atomic number is unique to each element, you could locate that on the periodic table. Hydrogen, H, the symbol, hyphen, mass number is another way to write it. Or we could spell out hydrogen, hyphen, mass number. All 4 ways are correct. If you are struggling on how to calculate for the protons, electrons, and neutrons, these equations might help you. Remember, atomic number is equal to the number of protons. It is also equal to the number of electrons for neutral atoms. There are 2 types of ions, cations. To find the charge of a cation, it is the number of protons minus the charge. The reason it is minus the charge is it loses electrons, so minus. Anions, the formula for charge is equal to number of protons plus the charge. The reason we add the charge is because it gains electrons. Mass number is equal to the number of protons plus the number of neutrons. How do we use the equation above? If the mass number is given, use the equation above to find the number of neutrons. Number 2, if the number of neutron is given, use the equation above to find the mass number. Number 3, if the mass number and the number of neutrons are not given, use the periodic table. Find the atomic mass of the particular element and round it to the ones place. Complete the table below. Sulfur, atomic number, is the whole number on top of your periodic table. It is 14 for sulfur. The atomic number gives you the number of protons. It is unique to each element. Since no charges were given, the number of protons will equal the number of electrons because this is a neutral atom. The mass number is the number of protons, or the atomic number, plus the number of neutrons. The number of neutrons were not given, so we need to find the atomic mass on the periodic table and round it to the ones place. So on my particular periodic table, the atomic mass for sulfur is 28.09. Rounded to the ones place, I look 1 to the right, so this is 28. How do I find the number of neutrons? The number of neutron is the mass number minus the number of protons, or the atomic number. So this is going to be 28 minus 14, which equals 14. In the next problem, the number of protons are given. We know that the number of protons equals to the atomic number, which is 38. If I look up 38 on the periodic table, it is strontium. Since no charge is given, that means the number of protons and electrons are the same. So this is also 38. The mass number is not given. The number of neutron is not given. We look up the mass number on the periodic table. Strontium has an atomic mass of 87.62. Rounded to the ones place, this becomes 88. The mass number is 88. The number of neutron is 88 minus 38, which is 50. Pause the video, fill in the rest of the table, and check your answers. 90 is the atomic number. It gives us the number of protons. So that is also 90. If I look up the atomic number, it is thorium. It is in the rare earth family. Since no charge is given, the number of protons and number of electrons are the same, 90. We do not look up. In this problem, the number of neutrons are given, so we do not use the atomic mass to determine the mass number. We're going to take the number of neutrons and we're going to add it to the number of protons to find the total mass numbers to get 234 for its mass number. Lead has an atomic number of 82. This tells us the number of proton is 82. Since no charges are given, our number of electrons are also 82. Here, the mass number is given, so we do not use the atomic mass on the periodic table. So the number of neutrons are going to be the mass number minus the number of protons, which is 82, which equals 182. Au is gold. If I look up gold on the periodic table, it has an atomic number of 79. That gives us the number of proton, which is also 79. Since no charge is provided, this is a neutral atom. Number of electrons are also 79. The mass number is given right here. Remember the format. Element on top is the mass number, symbol A, and on the bottom is the atomic number, symbol Z. Since the mass number is given, we do not use the atomic mass on the periodic table. So this is 196 minus 79, which equals 117. In the next problem, the number of protons given. So the number of protons is equal to the atomic number, so that's also going to be 74. If you look up 74, atomic number on the periodic table, it is tungsten. Since neither the mass number or number of neutrons are provided in this problem, we use the atomic mass. The atomic mass of tungsten is 183.84, and we need to round to the ones place, so this becomes 184. We know that the number of electrons are going to equal to the number of protons because this is a neutral atom. We know the mass number, 184, minus the protons will give us the number of neutrons, so this is 110 neutrons. Chromium has a mass number of 24. It tells us the number of proton is also equal to 24. Since this is a neutral atom, our electrons are also 24. Here, the number of neutrons are given as 32, so we do not use the periodic table. We take the number of protons, which is 24, plus the number of neutrons, which is 32, to equal 50 is krypton. It gives us a number of proton, which is also 36. Since this is a neutral atom, our number of electron is also 36. Our number of neutrons is the mass number minus the number of protons. Since the mass number is given as 85, it's going to be 85 minus 36, which equals 49. The number of proton is 53, so that's also the atomic number of 53. 53 is iodine. Since this is a neutral atom, because no charges are given, this is also 53. Since neither the mass number or the number of neutrons are given, we use the atomic mass of iodine off the periodic table and round it to the ones place. So this is 126.90. I round to the ones place, that becomes 127. So the number of neutrons is 127 minus 53, which equals 74. Pause the video, fill in the table, and then check your answer. Tc is technetium on the periodic table. It has an atomic number of 43. Atomic number always gives us the number of protons. If it was a neutral atom, it would also give us the number of electrons, but here a charge of 3 plus was provided, so the charge is 3 plus. This is a cation. Cation loses electrons. So the number of electrons will be the number of protons, or the atomic number, minus, because it lost 3 electrons. 3, so this is 40 electrons. Since the mass number or the number of neutrons are not provided, we need to use the atomic number on the periodic table, which is 98. It is already rounded to the ones place. The number of neutrons is the mass number minus the atomic number, or the number of protons. So this is going to be 98 minus 43, which equals 55. This is an ion because it's a charged atom. Since we read it off the periodic table, it is one of the isotopes. The next row, it has 4 protons, therefore the atomic number is also 4. 4 is beryllium, which is Be. No charge is given, so this is a neutral atom. So the atomic number also matches the number of electrons. Here, the mass number is given, so we do not use the periodic table. So this is to find the number of neutrons. It is the mass number minus the atomic number. So this is 6. We also have beryllium again in the next row. Atomic number is still the same. The number of protons is the same because it's the same element. This one is a neutral atom because no charge was provided. So the number of electrons will equal the number of protons. Here, no neutrons or mass number is provided, so we look at the periodic table to find its atomic mass, which is 9.0122. Rounded to the ones place, it's 9. So our number of neutrons is the mass number minus the atomic number, or the protons, so this is equal to 5. So this is also a neutral atom because there's no charge. The top one is also a neutral atom because there's no charge. And these are isotopes of each other. How do we know this is an isotope? Isotopes have the same atomic number or the same number of protons, but they have different number of neutrons. This one has 6, this one has 5. Since they have different number of neutrons, they have different mass numbers. The number of protons is 52, which is also the atomic number on the periodic table. This is beryllium, Te. It has a charge of 2 minus because it was given, so this is an ion, not a neutral atom. So that means since it has a -2, this is an anion. It has more electrons than protons. To find the number of electrons, we take the number of protons plus, because it has more electrons, 2. So this has 54 electrons. Since the mass number, or the number of neutrons, not provided, we take the atomic mass provided on the periodic table, which is 127.6. Rounded to the ones place, this is 128. To find the number of neutrons, it's 128, which is the mass number, minus the number of protons, which is 52, or atomic number. And if you do the math, this is 76. So this one is an ion because it's a charged atom. It is an isotope, but since it matches the periodic table, we'll just leave it as an ion. The next one has 23 electrons. The charge was not provided. We assume this is a neutral atom, so the number of protons must equal the number of electrons, which is also the atomic number. 23 is vanadium, V. In this problem, mass number is provided, so we don't use the periodic table. We find the number of neutrons by the mass number, which is 59, minus the number of proton, which is 23. This is 36. Here, it is a neutral atom. That is an isotope. Because on the periodic table, the vanadium, its atomic mass is 51.9. Rounded to ones place would be 52. So the number of neutrons or the mass numbers do not match. Therefore, this is an isotope. 85 on the periodic table is astatine, At. Since the atomic number is given, it is also equal to the number of protons. This is not a neutral atom. It has a charge of -1, so it has more electrons. So it's 85 plus 1, which is 86. Neutrons are not provided. We take the atomic mass provided on the periodic table, which is 210. Already rounded to the ones place. So our number of neutrons is the mass number, which is 210 minus 85, which equals 125. So this one here is an ion, but since we got the mass number off the periodic table, it's just an ion. 22. Atomic number is titanium on the periodic table, Ti. The number of proton is 22. It matches the atomic number. The number of protons and the number of electrons are not the same. So this is a charged ion. Since we have one more proton than an electron, this is going to be a plus ion. So it has a charge of +1 because there are more protons than electrons by 1. Since the number of neutrons are provided, we find the mass number by the number of neutrons plus the number of protons, or the atomic number. So this is going to be 22 plus 50, which is equal to 72. So we know this is an ion. If I look at the periodic table, atomic mass for titanium is 47.86. Rounded to the ones place, this is a 48. So if I look at this, this is an isotope. The mass number are not the same. This one has 2 protons, so that means my atomic number is also 2. 2 on the periodic table is helium, which has a +2 charge, so we know this is an ion. Since it's 2+ charge, we got rid of electrons, so that's going to be the number of protons minus the charge. So this is equal to 0. It has no electrons. This is a cation. The mass number given is 42 minus the protons. So it has 40 neutrons. So this is an ion. That is an isotope because the mass of helium is 4.00, so the mass number is 4.